Welcome to our video. Here we're going to explain about our project which we have done as Team MLDO, and we made a project based on SVM, also known as Support Vector Machine, uh, which is a model in machine learning. We have attended a workshop conducted by Mr. Nirma Gaud, and here we are going to demonstrate what we have learned from the project. So we picked a problem statement at the end of the project, and we have to demonstrate how we have gained the skill or the knowledge based on the machine learning methods that have been taught in the course of the workshop. We have made a prediction model on credit card fraud detection, where you can see the data set is not available in our GitHub repository right now because it is greater than 25 MB. But you can check the code whenever possible, and if possible, we are also going to pin the Kaggle dataset link to. So here's the demonstration of the code that we have implemented. First, we have the importing part where we import pandas as PD. This all the three statements here are from sklearn, which you can do with only one simple statement: import from import sklearn as sk or something. But we have wrote these three statements for a better precision in the code for you to read as well as understand the code in an easier manner. And then if we go to the next part, here we see df, the variable which we have declared, and pd, the pandas module which we are using to read the csv file, which can also be known as it is nearer to an excel sheet which has a lot of data. So we read all the data into the variable and store it. And then here we see the none values, as well as there may be chances where there are several columns. You can't read each and every column, right? You don't have that much time. While doing the code, we have filled the missing values or null values with the mean of the particular column. So the missing values will be filled with the mean of each column variable. And then we draw the class as the only target variable for y, and rest all is taken as x, which are also the attributes here. And then we use the train test split function, where we specify the test size. The test data set which we are going to use is going to be the 20% of the original data set which we are using. And this random state is a random state from which the machine is going to start its prediction. And then we are going to specify the model here. Here we are using SVC, which is also known as support vector classifier. And here we are also going to give a random state for the reference for the machine learning model to start its prediction. And then we are going to fit the training data set. Here the training data set is going to be 80%, as we are going to take the 20% out for the testing, and we are going to take the rest of the 80% for the training data set. And here we are specifying it as end because SVC needs numerical values or numerical inputs to derive or occur at a conclusion. And then we have to predict the y predict or the prediction based on the training data sets which we have given to the model. And here we predict it with respect to the x test. So we are only going to pass the x test or the test data set which only has attributes, which has no class. So this is going to be given as the x test, and it is going to make its prediction, and it's just going to give respective y values. Now here we are using different accuracy scores or metrics which are used to see how close the machine is with the actual data set that has been given to us and the prediction which we have done. So at last we are going to calculate all this, which is accuracy, precision, recall, F1, and ROC. All these scores are going to be produced at last, and these are the scores that we have achieved due to the course of the project. And the detailed summary as well as the points which we have used is going to be found right here in the README file right now, which you can see on the screen. And thank you for the opportunity. Thank you for the opportunity from our college to showcase our talents in the workshop that has given us a lot of info on machine learning. Thank you.